Assalamualaikum and a very good day to Dr. Shed and Dr. Shelley. So my name is Muhammad Nur Azmir and I would like to present about my FYP project, which is simulation based modeling and analysis of fan engine casing. For the introduction of research topic, aerospace industries is a strategic industry that contributes to the economy of Malaysia. Anodizing and epoxy process are the main process in the plant. Fan engine casing is one of the component of aircraft engine and product produced. As you can see in the graph, which is the gold color is the fan engine casing. So for the problem statement, a key performance indicator is cycle time and production quantity. The main process including the visual inspection, anodizing inspection, rework store, epoxy, curing, and final inspection. From the main process, three factors of each process was analyzed, and we found out that six critical factors was observed that affecting the key performance indicator. So the validation factor consists of number of workers for visual inspection, manual handling time for store rework, and number of anodizing machine. And the experimental factor consists of epoxy curing time, anodizing machine processing time, and number of epoxy machine. So for the research objective, first one is to develop and verify the conceptual model of fan engine casing manufacturing system. Second, to develop, verify and validate the simulation model of fan engine casing manufacturing system. This is done in FYP1, and for the FYP2 is to analyze and improve the performance of fan engine casing manufacturing system. So next is literature review. So there are three types of literature review study, which are first one is simulation studies related to fan engine casing manufacturing system. So there are five studies. Second, non-simulation study related to fan engine casing manufacturing system, 10 studies. And the last one is the simulation studies related to other manufacturing system by using arena simulation, which is 20 studies. So for the research gap, as you can see at the literature review, simulation is becoming popular for other manufacturing industries, but it is not popular for studying fan engine casing manufacturing system. And the factor that we wanted to analyze is not well researched into compared to the factor mostly studied in the existing literature. So by that, Arena Simulation and SPSS is the selected software to do the study. So based on that, the scope of study is the to focus on the analysis and improvement of the case study company. Next is methodology. So this is the methodology flowchart in this project, which is starting with industry training, and from the industry training we get the data collection as well as we find the literature review. And then from that we come out with the problem statement, then go to the conceptual model, simulation model, to the verification of simulation model. Then we validate validation of the simulation model. This is was done for the FYP1, and then for the FYP2 we done with the simulation experiment, which is consists of the SPSS also. And then from that we use the statistical result analysis and then proceed with the thesis writing. This is the conceptual model that are used in the arena simulation. As you can see in the figure 1, which is we use the number of replication is 700. The warm-up period is 600,000 hours, and the replication length is 608,760 hours. So this is the validation graph got from the result of the arena simulation. In the figure 2 shows the production cycle time against the number of workers for visual inspection and different types of minutes, which is, as we can see here, as the number of workers is increased, the production cycle time will remain the same. This is because the number of workers does not have significant effect on the production cycle time, while if we increase the number of minutes of manual handling, it shows that the production cycle time is increased as well. So we can see that the manual handling has a significant effect and the graph is valid. While for the figure 3, it shows that both of the factors does not have significant effect and the production side quantity is remain the same. Next, for the result and discussion. So this is the experimental graph. So this is the result from the arena simulation. In this slide, I only show for the cycle time only. So for the factor 1 is the anodizing processing time. As shown in the graph, as the anodizing processing time is increased, the cycle time also increase. Same goes to the epoxy curing time. As the epoxy curing time is increased, the production cycle time is increased. So for the next graph is factor 2, which is the number of epoxy machine. So as the number of epoxy machine is increased, the production cycle times remain the same. But if we increase the hours, the time for the analyzing processing time, the production cycle time also will be increased. So for the third graph is the epoxy curing time. As we can see in the graph, as the epoxy curing time is increased, the production cycle time will be increased. But when we increase the units of epoxy machine, the cycle time will be remain the same. It shows that uh, when the factor is play with the cycle time, although it increasing or decreasing the time, the production time will remain the same. But when we change the unit of the machine, the production cycle time is remain the same. As we can see also here, we can conclude that if we increase the time for the factors, it shows that the production cycle time is increasing. It shows that it not significant for the plant because the cycle time is increased. It will affect the production. So for the ANOVA analysis, table 5 shows the performance analysis for three selected factors. So the dependent variable is cycle time. So the red rectangular box is shows that the three factors, which is from the variation given in the table, we can identify the significant parameters from the F-test for each factors. So the most significant contributions comes from the epoxy curing time, which is the highest F value, followed by anodizing processing time and then epoxy machine. So another way to find the most significant contribution is by the main effect graph. So as we can see in the figure 9, the epoxy curing time has more steeper on the slope compared to the anodizing processing time as shown in the figure 8. So that's why the epoxy curing time has the most significant factors, while for the number of epoxy machine, it shows that the line is horizontal, so there is no main effect. This is the interaction effect graph for the cycle time. There are a total of 6 graphs, which is one factor have 2 graphs. So in the slide we have 3 graphs, which is all of the graph has not shows the line is overlapping. So this is because of this is a two-ways ANOVA analysis without replication. So it will be assumed that there is no interaction. For the limitation, there are some of specific data that cannot be taken due to the confidentiality of the company. Second, in the existing company, some machine link together and different speed and the length of the conveyor runnings, which is difficult to find the cycle time. And then for the recommendation, develop a simulation model with higher resemblance possible compared to the real system without oversimplification. Second, run the simulation with longer replication length to ensure that a representative sample state response of the simulation system is taken. So that's all. Thank you very much.